Hello everyone. In today's lesson we will be studying coupled differential equations, which is a topic in the IB Math AI high level. I will show you how to get the exact algebraic solution to coupled differential equations step by step. So let's start with the formula here. This is the formula for the general solution of coupled differential equations, and it's given in the formula booklet. Here x is not a variable, it's a vector xy. We'll talk about it later when we solve. A and b are constant numbers. Here lambda 1 and lambda 2 are the eigenvalues, and of course p1 and p2 are the corresponding eigenvectors, which means of course to find the solution to these you need the eigenvalues and the eigenvectors. Now before we start here, I made a video about the eigenvalues and vectors and how to find them in details. The video appears top right of the screen. So here we have a system of equations. We need to find the eigenvalues and eigenvectors. Now here, to do it first, we will have the matrix, which is, by the way, as you see, 3, 5, 1, -1. We put it here in a determinant form like this. We put only the coefficients of x and y, 3, 5, 1, -1, as you see here. But of course, as we know, when we find eigenvalues, we subtract lambdas only from the main diagonal like this. Then we make the determinant equal 0. Now keep in mind, this is a determinant, not a matrix. So it can be expanded and we can have a single value. When you expand it, you multiply 3 minus lambda by this, -1 minus lambda, as you see. Then always minus from the formula. 1 multiplied by 5 will be 5, equal to 0 as it is. Now here, if you expand the bracket here, you will have easily this expression here. Then minus 5 here, we shouldn't forget it. If you rearrange this, you will make a quadratic equation in lambda. And when you factor it, it will be like this. Lambda minus 4, lambda plus 2 equals 0. Here, the two solutions or the two eigenvalues will be either 4 or -2. So we have two eigenvalues, as you see. Now, here, after we found the eigenvalues, we will of course find the corresponding eigenvector for each one of them. Let's start first with the eigenvalue 4. So here we have the eigenvalue 4. To find the corresponding eigenvector, you plug in this 4 back here, but you make it a matrix. See here, 3 minus 4 would be -1, 5 and 1 as they are, and here -1 minus 4 would be -5. Then we multiply here by the column vector xy and we make it equal to 0. This is the way how to find eigenvectors. Again, it's explained in that video I told you about in the beginning of today's lesson. So here, if you expand, you multiply -1 by x and 5 by y. You will get this. No need to multiply these because you will get an equivalent equation that doesn't have anything or any other solutions. So -x plus 5y equals 0, which means x will be 5y. Now to find an eigenvector, you can replace x or y by any number you want. Any number except for 0. Preferably here we can replace y by 1. Then x will be 5 by 1, which is 5. So x is 5 and y is 1. This will be the this will be the eigenvector corresponding to this first eigenvalue 4. Now someone might say, what if I replace y by 2? No problem. You will get x to be 10. Which is another parallel vector to this, which also works. Now, similarly here, we will find the eigenvector corresponding to the eigenvalue -2 in the same exact process. Here, to find the eigenvector, you replace lambda by -2 everywhere here. You will have here 3 minus -2, which is +5, 5 and 1 as they are. Here -1, -1 minus -2 will give you +1 at the end. Also xy equals 0. When you expand, it's enough to multiply 5 in x and 5y here. So you get 5x plus 5y equals 0. If you divide by 5, x plus y equals 0. Move x to the other side, so y will be negative x. If you replace x by an optional number 1 here, then y will be negative 1. So 1, negative 1 would be the eigenvector corresponding to this eigenvalue of negative 2. So here, as you see, we found the two eigenvalues and the corresponding eigenvectors, and we've done question A fully. If you do it, of course, like this in the IB, you would take a full mark. Next, B. Hence find the general solution to this system of equations. So now we will talk about this. Here, x actually is a vector like this, x, y. P1 is the eigenvalue. So here, we can say that this is lambda 1, so the first eigenvalue, and therefore this could be P1, the first eigenvector. Here, lambda 2. And here you can say that this is here P2. So this is here the second eigenvalue, and here eigenvector. Or you can you can make this one lambda 2. It doesn't matter which one is lambda 1, which one is lambda 2. The order doesn't matter. So now we will plug in these in this general solution. So now for question B, we will write it like this. Here xy equals here, as you see, first we have constant a. So we have a multiplied by e to the power of lambda 1, which is 4, multiplied by t, times the eigenvector corresponding to lambda 1, which is here 5, 1, plus then we have b, the other eigenvalue here, lambda 2, which is negative 2 in our case, multiplied by the corresponding eigenvector here, 1, negative 1. That's it. So this is the general solution to the coupled differential equation. But sometimes an important question might come. We need to find a particular solution that satisfies this initial condition given here. This is here a general solution. Here we have infinitely many solutions for lots of constant values of a and b. But sometimes they ask you for a certain value of a and b, so they give you here a condition. Now, initial condition means the time, or t, is 0. So we will replace x by 2, y by negative 1, and t by 0 here in this now. So in question C, we will replace the x and y here by 2 and negative 1, as you see. So here now 2 and then negative 1 equals, you keep a as it is. Now notice that here t is 0. So you will replace here t by 0, then e to the power of 0 will be 1. 1 multiplied by anything, you can ignore it. You will have 5, 1. Plus b, in the same way this e will be 1, so you have 1, negative 1. That means now, look here, 5 multiplied by a plus b times 1, or b, equals to 2. So we can make the first equation here, 5a plus b equals 2. Then in the same way, we have here a by 1 and here b by negative 1. So 1a minus b equals negative 1. So here, as you see, we have a system of equations. You can of course do it only by the GDC, like you are an AI student, so calculator is allowed in any paper, so you can just do it by calculator, or if we do it easily, quickly here algebraically, we can just add them up. 5a plus a would be 6a, b and negative b cancel each other, 2 and negative 1 will be 1, so if you divide, then a will be 1 over 6. So now you can replace the a here. You will have 5 times a, which is 5 times 1 over 6, and that will be 5 over 6, plus b equals 2, which means b will be 7 over 6 if you solve here easily. But of course, I recommend doing this only by calculator. Since we found a and b here, we replace them back here in this equation. So here we will have now the same solution, but we replace a and b by the numbers we found, which is here 1 out of 6, and for b it's 7 divided by 6. So this is all about coupled differential equations. I hope that you found this explanation helpful. Please hit the like button and consider subscribing to the channel. Thank you for watching.